Okay guys, now it's time to calculate percent error with your density lab. Now percent error has a certain formula, and this is on the back of the page that I gave you instructions. It said you're going to take your experimental value minus the accepted value okay, and that equals your error. Okay, all that means is how much you missed by. So you're going to take what you got in your experiment minus the accepted value. I'm going to give you that number, the known accepted value, okay, and that's your error. Well, all you're going to do for your percent error, what's your percent? It's how much you missed by. What is your error divided by the accepted value? Times 100. So let me show you an example. Okay, so let's say, and these are made up numbers, these are not exactly right. Okay, so let's say you did the experiment, and I'm going to use fake numbers, so this is not going to be real, but you had a metal, and in your substance, in your experimental data, in your experiment, so it's experimental is your experiment, you came up with 2.12 grams per milliliter. Okay, you got the mass, you got the volume, you calculated the density, and you got it to be 2.12 grams per milliliter. Now, I will give you, and you will find a data page that has your accepted values on it. And by the way, I check all your numbers, so you can't fake your numbers, because if you fake them, you'll lose all credit. Okay, and so I'm going to give you the accepted value. Now, I'm going to be honest with you. Most people, you're not going to get this number every time. We don't have the best equipment completely in the world to do it with, but this is the accepted value, and let's say it was 2.32 grams per milliliter. So it is known that that substance has a density of 2.32, and you got 2.12. So we're going to do exactly the math that would be involved in this. So the formula said take your experimental value, 2.12, and you're going to subtract 2.32. So I'm going to take my handy dandy calculator. 2.12 minus 2.32 equals negative 0.2. Negative 0.2. Now, why is it negative? Because you were under. That negative just means you were under the value, so don't let that negative freak you out. Some of you will have a positive. So if you would have came up with 2.42, you would have had a positive number because you were above. But I'm going to use the 2.12. Okay? So this is my error. I just missed by this much. So what was the equation for percent error? You take your error on the top, which was negative 0.2, and you divide it by your accepted value, 2.32, and then multiply by 100. Okay, and so what you're basically figuring out is what's the percentage I was off by. So you're going to take that negative 0.2 and you're going to divide it by 2.32, and then you're going to multiply it times 100. And I have, if these were my numbers, a 0.86% negative error. You may think, is that good? Yeah, that's really good. I was pretty close to the answer. Okay, and so you're hoping that your experimental value is very close to your accepted value, but sometimes it's not. Okay, so you shouldn't have a percent error in the 100%, 200%. You did your math wrong. Okay, so how did I do that again? I took my experimental number minus the number that Mr. Kelly gave me, and that's how much I missed by. Take how much I missed by the accepted, divided by the accepted value times 100, and there's my percent error. So you're going to do your percent error for each of the substances that you did in the lab.